Alright everyone, welcome to Advented Code Day 7. I'm finally here with like over 10 seconds before the day starts, so we're doing good. Base code's already up, input files ready, run it's all good. So we're all ready for today's puzzle. Alrighty, here we go. 5 seconds here. Let us get into today's puzzle. Hopefully it's still not too bad, but you never know. We're still waiting for that one hard one. You can hear birds chirping and raindrops in the leaves as the prediction proceeds. Occasionally you can even hear much louder sounds in the distance. How big do the animals get out here anyway? This device the elves gave you has problems with more than just its communication system. You try to run that system updates. Please ensure on top, no space on the device. Perhaps you can delete some files and make up the space with updates. You browse on the file system, access the situation, and save the resulting terminal outputs, puzzle inputs, for example. Okay. File system consists of a tree of files, plain data, and directories which can contain within which the lines begin with our commands you executed, very much like modern input. CD means change directory. I know CD works. ls means list. File name ABC with a size of 1, 2, 3. So it's size and then it's dir. Okay, that's fine. Again, the file system looks like this. Here there are 4 directories / outermost a. These directories have contained 5 files. Since the disk is full, your first step should be probably to find the directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. Total size of a directory is the sum of the sizes of the files it contains, directly or indirectly. Directories themselves not count. E is file. Contains F, G. Okay, directory D. So, okay, so you can find all the directories with a total size at most, and all of the directories with a total size of at most 1000, and then calculate the sum of their total sizes. In this example above, these directories A and E, the sum of these total sizes is that. Okay, so fun. Parsing. Today is all about parsing, is what's going to come down to. So what we're going to need to do is we're going to still be going line by line for this today, string s and inputs, and we're going to need to keep track of our current path or our current index, so to say. And we're going to be basically just building a tree. So I'm going to be lazy and we're going to make this a map. This map is going to be a string, and then it's going to be an object. And this is going to be map. I'm not a fan of this. No, let's do this right. Let's do this right. Let's actually make classes for this. I'm going to be just a little slower, but let's do this kind of right. So we're going to have a node here. Whoops, class. And then we're also, each node, there can be a file and a folder. File, folder. And so we're gonna have folder root equals new folder. And so that's the roots. This is what we start with. Technically, I think our input gives us cd/, so technically the root, we'll just parse out the first line as this, and we'll count that good. So the root is going to be a new folder, and then a folder is going to have a list of nodes. This needs to extend node, by the way. Same with file here. And this is going to be contents equals new array lists. We'll make this public, why not? Whoops, public. Cool, and then node, cool. We can make it static. Sure, we'll make the compiler happy. We'll make Java happy, make it all static. And so what we're gonna do is I'm gonna change this to int I equals 1 while I is less than input dot size I plus. Cool. And we're skipping 0 because 0 is our root. So we need a path. We can do this. We can do node and we can do current. And we can use current node. And we can use this node here as our pointer of where we currently are. So our node's actually going to sit at root, and we're going to go from there. So now we need a switch statement. Actually, we need to do string s inputs get 0. And what we're going to do here is now do a switch statement on, I think it's just going to be s dot substring from 0 to s dot index of a space. No. Never mind. We're gonna break this up into parts. Input split on space. So let's go case by case here. So if parts 0 equals the $, this is running a command, which in this case ls. This is going to tell it. So we're going to have to adjust this. I think we actually might as well make this a while loop. Break this out here and just do while this, and the internals here with control I. Because then no, we don't have to. Let's see if we can get away without doing a while loop here. I think we can. So let's parse out the command so we know it's an ls, so that means we're going to be listing out. So for now we'll skip it. Else if parts 0 it's either going to be dir or a number. So we'll just do dir first. And then we'll do an else down here. So for directory, we're gonna have to do current node. And so we're gonna need to do we're gonna do folder equals new folder. I think these all have names, right? So yes, so a node still is a name. So we'll do folder dot name is going to equal parts 1, I think. Yes. Cool, that makes that easier, and then we can just do current node. Oh. Well, it has to be a folder, so we don't have to worry about node. So we can actually do current folder, actually. Because you can't do a file doesn't work for the current node, if that makes sense. Contents, add folder. We initialize it, right? Cool. So that makes that easy. Here it's a file instead. Whoops. File equals new file. File.name is still parts 1, but now a file is going to have an int size. Make this public. Doesn't really matter, but I'll make it public anyways. And we'll do file.size equals parts 0, and we gotta parse int it. And there we go. So now we have correctly gone through. So ls we can safely ignore. All we are going to be caring about is cd. So if we get ls, actually we can ignore it because we just know we're going to be at the current node and we're going to be adding it in. That's fine. So we're going to be doing if parts 1 equals, it's going to be cd. Then we didn't know what type of CD it is. CD is going to be, if we go, this is going to be going into a certain one. So if parts 2, actually, so we should check for the dot first, because that's going to go back, right? Which in this case, A folder should have a parent. So on node, what we're going to do, public folder parent. And then every time we do a folder, so we can do folder.parent equals current folder. File parent is current folder. And so what we can do then is just do current folder equals current folder dot parent. Easy enough. Otherwise, we need to go through node n in current folder dot contents if the node name equals parts 2. Then we can go ahead and set current folder equal to node. And we technically should make sure it's a folder, but I'm going to bypass it. It should be, you should check. I'll make that note, but that's fine. And then break. And I think that should be all we need for building the tree out. That should build our tree and we should be good there. So now the question is, we need to go through our tree, find all the directories of the total size of at most that many. A and E. Okay. So what we're gonna have to do is on folder, we need to make a method, public long get size equal size, and it's going to return we need to make this abstract. Oops, class. We need to throw this get size on here. Make these add it, because this is going to return size. And all this is going to do is this is going to just do for node n in contents long size, and all it's going to do is just do size plus equals n dot get size, and then return size. Cool. So after we build this up, we need to go have a list of folders, new array list, and then we need to do we're gonna have to kind of flat map this to get all our folders, right? It's just A and E, because B, it's just folders, right? Or directories. Of at most. Yeah, so the processing count file is more than once. So we're gonna have to flat map this, and the easiest way actually is to do this and just go while to check size is greater than 0. Just run here, and all we'll do here is do to check dot add all. I'm gonna actually go ahead and in folder, I'm gonna make a method here called get subfolders. So I'm just gonna get lazy here. Folders, and if an instance of folders add n folders. Okay. Cool, and add all, and it's gonna be root, get subfolders. Cool. And then what we're gonna do here is we'll do to check remove 0. So it's gonna be folder F equals this. We're gonna have to go to check add all F dots fold, sorry. Get subfolders, and then if folder get size is less than or equal to this, add folder. And we should be good now. So this has them all, and so all we need to do is sum this all up for folder F. This is gonna be really kind of slow, but should be fine. Okay. Call it smaller folder, sure. Sum plus equals F dot get size. And then lap sum. Definitely not the fastest way to do this, but this should be fast enough. Unless we get 0. Huh. Oh. Root dot name equals slash, by the way. Interesting. Why? Because it might help if we don't do input get 0. It might help if we do input get I. Hey, look at that. We actually get an answer this time. Hey, we got it right. 480. I thought I was going to be doing that slow. Now you're ready to choose a directory to delete. The total disk space available file system is that. To run an update, you need undisk space, at least that. You need to find a directory you can delete that will free up enough space to run the update. An example of the total size of the outermost directory, and thus the total amount of your space, is that. The unused space. This means that the size of the unused space must currently be, which isn't quite the 3000 required update. Therefore, the update still required directory with the total size of at least. So we have to find the smallest directory that, if deleted, will free up enough space. So the totals, okay. So given this, so we're gonna have long, and then we're gonna have long. Technically, you don't really need to do this, but I'm curious. So minus sum. And now that we have freed up enough, we need to find the free space that we need to get at least 3000. So we need to do this again, except we don't care about smaller folder, we care about folder to delete. Which is going to start as root. That's fine if it starts as root. Well, it'll get changed. Go back to check to be into that. Go through them all, and then the changes here is we need to get if free space plus folder get size is greater than if folder plus free space is greater than this, and is less than, I need to keep a long here, long not math, no, integer.max, sure. I think that's right. And what's this asking? Total size of that directory. Lap. Technically it's smallest free, so technically I don't need this, I just need smallest free. Does this work? Nope. Curious, given the input, given the example input, what does it say the smallest free is? So A doesn't free up enough space. So something's wrong here. Because sum is wrong. Right. No, this needs to be root get size. So it was working. I just didn't do that logic right. Okay. So let's put our input here. We now get this. Wow, it's still not right. I get the right answer here though, right? 29. Interesting that it's not, mine's not right. There's a way to like do this in there's a way to like solve this. Really? So there's something, so I'm not, my logic was just not be right. Free space plus size. It's greater than that. And free space plus size is less than smallest free. Ah, because smallest free is being set to size. That's wrong. I just want size. Get rid of that. There we go. I fell off the leaderboard, but There we go. I just, some logic was wrong. But hey, honestly, I thought I was going to be really much further down because again, this is, I would say, if you're looking for doing this in terms of like the right way to do this problem, in terms of like, you know, in the real world, if you had to actually implement this in software, this is the more correct way to do it, because it might be a little more verbose, but it's easier to read, easier to understand, and is actually doing what the problem's asking of having a tree. Ignore malwarebytes. Of actually having a tree, building the tree up and whatnot. Obviously, you might be able to do this a little bit more succinctly than this, but class and structure and kind of object orientation way, this is the more right way to do it. That being said, there are faster ways to do this that aren't quite as verbose or as easy to read. So, but yeah, I don't think there's anything I really need to update. Honestly, I could probably make it faster, but I mean, how fast was this? 9 milliseconds. That's still not much. I mean, yeah. So let's just go over how to solve this problem. So for today's problem, you are given an input of, your input is a series of commands and the outputs of those commands. And from these, you need to build a tree of the folder structure on said device. And then from there, answer some questions that they give you. So the input file here, it gives you, you can run the cd command as well as, you know, the folder you want to run it on. The ls command to list out the contents of said directory. And again, cd to change the directory, either go into one or go back out of. In terms of ls, when it lists out the contents of a folder, if it is a number followed by text, that is a file. So this is this file size, this is the file name. If it is directory followed by some text, this is a directory as it specifies, and this is the name of the directory. Given this, we need to parse the inputs, and in this case, we need to build it into a tree. We have a root node, which is, again, our input always starts at the CDing into the root node, so we can just simply skip over the very first inputs and just already kind of create our root node there. We then have a folder, which we keep track of the current folder we're in, and from there we can then go up or down depending upon the commands we're given. So to solve this, or to actually parse this through, we have a nice big for loop here. We then take the line, we split it up by spaces to get the individual parts. We first check if the line starts with the $sign. If it does, we know we are running a command. If it doesn't, we know we are looking at a file output. Starting with the commands, the only command we really care about is cd. If it's an ls, we already have the directory we are currently in from cd, so we don't actually care about parsing ls. We just skip over it. So if we have a cd, all we care about is it the ... which means to go up a directory. If it is, we simply call the current folder we're in, get the parent of it, and set the current folder to the parent of the current folder we're in. Sorry, I said that backwards. But that's all that ... means. If it isn't ... that means we are cding into a folder. So we simply just loop through all the folders in the current folder we are in, find the one with the name that matches the input for part 2, so what you specify after cd, find the one that matches, set our current folder to that. I probably should be checking this as a folder, but for this input, it's safe that it is a folder, and then break out and let the logic continue. If we do not get a $sign to start our line, we know we are looking at a file or directory outputs. If we see the line starts with a directory, we know we are looking at directory outputs, and we simply create a new folder, set the parents of this folder to the current folder you're in, set the name to be the second part, the part that comes after the directory, and then add this folder to the current folder, the contents of the current folder. That way we can access it later. Lastly, if it's not a command and it's not directory to start the line, it'll be some sort of numbers. That way we know we have a file. Again, create the file, set the parent of this file to be the current folder we're in. Not totally necessary, but we do. Set the name of this file to be the part that comes after all the numbers. Again, not quite necessary, but we still do. Set the size of this file to be what is the very first part of the input, which is, again, part 0. Parse that out, set the file size, and then again, add this to the contents of the current folder we're in. That builds the tree out. Not too bad. Now that we have the tree built out, now we can go about finding all the files, and in this case, the first question asks us to find all of the folders that have a size that contain a total size less than 100,000. Basically, this comes down to flat mapping our folders, basically taking all the folders and just flattening them up into kind of one list with the size that they have. To do this, we simply keep a running list of all the folders we have encountered. You'll see more in a second, as well as keeping a list of all the folders that we have checked that have a size to be less than 100,000. This while loop will run as long as there are folders still left to check. Very first thing is we remove the folder from that toCheck method. That way it's no longer to check. Grab the folder and then add all of the folders within this folder to our toCheck method, because we now revisit this folder, but we still need to check all the folders under it. That's why they all get added to the toCheck, and that is how this kind of flattens them all out. Then we can simply just get the size of this folder. If it is less than 100,000, we can then add it to our running list of this folders less than 100,000. And then after this runs, after we have run through all of the folders, all of the child folders of those folders, and this toCheck is now empty, we can now go ahead and sum all the folders we have found to be less than 100,000, and now put that, and that is part 1. Not too bad. It's a little intimidating, but if you can get the concept of this tree down and understand how to parse it and then navigate through it, it's not too bad. Trees are very helpful to know. But that's part 1. Part 2 asks now to find the smallest folder that we have available to us and then remove it, or the smallest folder we can remove that will give us enough free space to install our updates. This comes down to, again, flat mapping all of our folders, but this time instead of finding the folders that are less than 100,000, we need to find the folder that will give us that will increase our free space to be above, it's like 3 million, 30 million I think, that increase our size above 30 million, but then find the smallest of the ones that do. And that's what this second bit here is doing. It's finding the smallest one that does get our space above 30 million. And then from that, now we have our smallest free, output that, and that is all we have. There we go. Day 7 is complete. Hopefully you guys enjoyed. I'll see you guys all tomorrow for day 8. Peace out.